All right, so let's continue from where we left off. So you're not getting the IP address, it's ifconfig-a, ifconfig-a. So ifconfig is a command that is to get the IP address. -a. Yep. So the IP address is 192.168.0.10.
10, right?
192.168.168.0.
Oh.
Yeah. Can you also open the presentation that we were discussing last class? Let's continue from there.
Yeah, sure. Yeah, you got it.
Sure. So which slide did we stop at?
It was
We discussed this, all these things, WC, find, and echo. We talked about these things, right? I think we stopped right here, correct? Here, this point?
Yes. Right.
Okay. So let's talk about it from this. We completed VI editor, I guess. VI editor.
Yeah, we do.
Right. Okay. So today we're going to talk about pipes and filters. Pipes and filters are one of the important functions in Unix. They provide an important application. So what is a pipe basically? So pipe is basically a way with which you can type commands at the same time. So for example, who command. So what is who command? The who command is a command that is used to display who is logged into the machine right now. Right? So who is logged into the machine right now? W shows who is doing what, right? And I can combine two commands with this one command. So all I do is W and then 5. So W-L. This command will basically this command will basically give me the number of lines in this W output, right? So W is basically the command used to display the number of there is users logged in and who's doing what. But if I want to display, but if I want to grab the number of lines, I do W pipe WCFNL. So this pipe command is a very important command. You can use any 2 commands, 3 commands, 10 commands as well. So all you do is you put pipe in between 2 commands, and what it does is it takes the input of this command and puts it as an it takes the output of this command and takes it and puts it an input to this command. So the second command is an input to work. And where does the input come from? That input comes from the W command, right? So W command takes the output from the previous command and gives it an input to this command, right? So if this command doesn't have any input, it's not going to work. It'll blank, right? So it has to have something. So these 2 commands are related to each other. This has to give an output, and this has to have an input from the command, right? So like this, you can keep doing pipe, and you can give how many other commands you want, but those commands have to make reference. They have to basically have some meaning to them. Without that, it's not going to work, right? Let's see some other examples of pipe. So I can say ls-l. I can again do the same wc-l. So it'll split ls-l output, and it'll count the number of lines in that, and it says 34, right? So I can do ls-l, and ls-l if I do who has R or who, it doesn't pick. So this command doesn't need an input at all. This output is completely neglected, right? So who command doesn't need any input at all. It just works to an input. So that is the reason it doesn't need it. So I can do mkdir. So again, if you do like this, again, this command doesn't need any input from this command. So the pipe is only used when the second command needs an input from the first command, right? So did you get the concept of pipe? Any doubts here? No? You can put it in the chat if you have any doubts. So feel free to put it in the chat if you have any doubts, and I can clarify right away. 34. Okay, 34 is basically the number of lines, right? Does you see this one? There is a lot of files. All this comes to 34, right? If you count this number of lines, it comes to 34. Right? WCFNL will come to 34, right? 35 now because I created a new directory called test. So that increase the number to one more, 35. Is that clear, Ramon? Is that good now? Any doubts? Did they clarify a question, Ramon? Directory, right. So I did mkdir test. Did you see in that pipe command that I did mkdir test? So if you go to history, and I hit enter, you will see that I did this command, right? This command. So before this command, the output was 34, and after this mkdir, the output became 35. Why? Because I created this directory here, and that is the reason that the number of files and directories became one more, right? And then I executed this the lsfnl. Instead of 34, it showed 35, right? Okay. So let's continue then. So that is basically about pipe. So pipe is a mechanism which takes the output of one command and gives the input to the second command. So next we talk about filter. So filter, what is a filter? So filter is a mechanism by which it modifies your output and it gives us an input to the second command, right? Or you can just display the output like that by modifying it. So the modification could be of anything. The modification could be like taking some parts out of it. The modification could be like modifying it in a different format, direction, sorting it, taking some unique values out of it. So that is what is known as filter, right? So filter is used to extract lines which contain a specific pattern, arrange them in a specific order, replace something in it, or merge files. So let us see what is the most common filter. The most common filter is a sort command. Sort command is the most common filter. Let us see an example of the sort command. So I go to the server and I put sort -n numerical value. So all I do is I type some random numbers. So 7, enter 2, enter 100, enter 38, 54, 32, and I do control D after this. There you go. So after 32, it arranged everything in ascending order: 2, 7, 32, 54, 78, 100. Right? You see that? So this is how the sort works. So instead of that, I can also put it in a file. So vi file, and then I can put the numbers here. I can put 2, 5, 8, 100, 34, 56, 21, and then 90, 78. So after that, I save this file, and I can do sort -n this file. Should do the same thing. There you go. It arranged everything in ascending order, right? So this is what sort does. Sort arranges everything in ascending order, and the same thing applies to characters as well. Characters and words. So we can do the same thing with them as well. So vi, let me put a file called ca. Start saying apple, zebra, rat, bad, right? And then I save this thing, and then I cat, yeah, or I can do, yeah, this is another way of using a pipe, and then sort. That's it. So that sorted everything in alphabetical order, right? Or I can do sort CA. There are two ways of using sort. One is using the cat command and then a pipe in between it, or I can just do sort CA, right? So these are the two ways of using sort. So sort can be used to sort anything you want, either reverse order or alphabetical order or numerical order. Therefore, I want to sort this reverse way. Sort -R, so it will bring the zebra at the top, right? Sort -R will bring the zebra at the top, and just sort will basically sort in alphabetical order, right? This is basically about the sort command. Next, let's go to the grep command. So what is grep? If I do cat CA and then pipe, and then I want to grep for a particular word, this one. I don't want the exact output. So imagine a file has got 10,000 lines, 20,000 lines. You cannot visually see the file to understand what is going on. So in that case, you have to use a pipe. So grep, and then I will get a particular word. I want to get a word called goat. So cat, there is grep for goat. So what it does is it exactly displays the output that has got code in it, right? So let me show you another example. We have this file. I'm going to add some lot of entries here. I'm going to copy this goat to like 10 different places. YY, and then P, and then paste here, and then paste here, and then let's show you the same thing. So cat CA grep goat will show me goat in all those 4 places, right? So this is how you basically get a pattern within a file. So imagine if this file has got 20,000 lines, and I want to grep for a particular pattern or a word. This is how I do it. So imagine if it's got like a lot of lines. For example, there's a file called Anaconda, and this has got a lot of lines in it. Now what if I want to grep for Pam? So I just do a pipe and then grep Pam, and it displays wherever the word Pam is in the file, right? So this applies to any file. The pipe and the grep can be used on basically any file, right? So the other options for greps. Let's look at some examples. What are the grep examples that they have? So one is -I. -I is a very important thing. Let me show you why. So VI, CA, and at the bottom, and I add another goat here. GOAT, GOAT, GOAT. So the difference is basically I have G in caps in one, T in caps once, and goat all caps, right? So where does -I basically come in? Let me show you here. If I cat CA and grep for goat, it will only show me the lowercase goat. But if I put the -I in it, -I is used to ignore the case. So I'm telling the grep command to ignore the case, uppercase, lowercase, just display me everything in spite of the case, right? Because by default, Unix OS is case sensitive. It only searches for what you ask. If you don't ask for lowercase, it will not search it, right? So for that reason, it only displays the lowercase by default. So if I grep for capital goat here, GOAT, it'll only display me the capital goat that I have there. That's it. So here, if I put -I here, again it'll become like same as the previous output. Ignore all this and display everything, right? So this is an example of like grepping without the case, ignoring the case, right? Any doubts to here? Any doubts in the grep command and the sort command that we saw? Any doubts? No? Okay. So let's look at the other filters that they have. One is egrep. Egrep is used to extract multiple patterns, more than one. So let's see an example of egrep. So with this grep, I can only extract like one pattern goat. What if I want to extract 2 things? I want to extract goat and cat. So I do egrep here, and I do double quotes, and I do a pipe, and then I add a cat, close the double quotes, and now I can basically grep for goat and cat. Looks like they don't have cat. Is there fat here? There you go, there's a fat. Is there a rat here? There you go, there's a rat. So you can add any number of patterns here, and you can basically grep out. So is there a pad here? There is a pad. So I can add any number of patterns to the egrep command, and I can keep grep for those patterns. Right? This you cannot do with grep. For egrep, you can search multiple patterns. With grep, you can only search for one pattern. Right? So egrep has the same options as the grep command. So the -I ignore the case, and you can grep for multiple words within a file. So you can also do the cat is basically just to display the output. You can also do it this way, right? What you can do is egrep the whole command, whatever the command is, and then towards the end you add the file name egrep ca. So this will exactly do the same thing as a cat command, right? So you don't have to use the cat command all the time. So egrep space the file name is the original syntax, but we use a cat ca to illustrate it easily, right? So any command will work like this: egrep space the file name, grep space the file name, right? So this and this produce the same output. This and this produce the same output. Both are exactly the same, right? So let's go to the next one. Next one is PG. PG is basically used to display page by page. So for example, PG space with anaconda file, that's a big file. What this will do is to display PG command not found. Oh, looks like PG is an old command, it's not used anymore, or we might have installed it. So the way PG works is it displays the output page by page. Yes, page is so yes. Grep command can also be used as the egrep without the cat command. So let me show you that. Grep cat ca and grep fat ca. There you go. So that also works the same way, right? So the grep command can be used just like the egrep command without the cat. So looks like the PG is not there, but that's another alternate command for PG. There is more anaconda the KH. So what this command more does is it displays the file in a page by page, and it also displays the percentage of how much the file is completed. So this is the first page of the particular file, and it's complete 55%. And if you hit a space again, it'll basically go to the next part, and this is the next page, and it's completed in 9%, and the remaining it'll show at the end, right? So more command is to display the file page by page, right? So the more command is very similar to the PG command. Looks like the PG command is not anymore, but the more command is still used. What is the next command? Okay, there you go. Next command is a more command. So more command is exactly the same thing as PG. The next command is a T command. Let us see what is T. So if I do lsfnl, so did we talk about redirection in the previous class? Does anyone remember what is redirection? Yes? No? Did we discuss about the wildcards and the redirection command? Yes, okay. So redirection is basically used to redirect the output to another file. So this lsfnl is used to redirect this to another file called temp/fan. So what this will do, if I cat/temp fan, so this whole output is displayed here in temp fan, right? So instead of this, so the way the redirection works is when you do this redirection, it doesn't show the output to your standard screen, right? It does not show the output to your standard screen. For example, who, if I display who, it will show me the output in the standard screen. But if I do redirection here to temp/fan, slash who log temp and p. So this does not show the output of the status screen, right? So this just gives the redirection. That's it. So I have to cat the temp who.log to get the output, right? So to avoid that, there is a better way you can do it. The way you do that is, instead of this redirection, you basically use the pipe and t command. Use a pipe and then t, and then you do who1.log, who1.log, and then you cat. Okay, so when you do this who t, you see that it displays the output right there in your screen, right? So it displays the output, and at the same time, if you cat this particular file, it will also have the output. So it does two things. One is it displays the output to you on the standard screen, and at the same time, it basically it basically puts the output in this file, right? With the help of redirection, you do not get the output on your standard screen, but with the help of the tcon, you do get the output in the standard screen and also redirects to the file, right? There is a difference between the redirection and the t command. So let me show you the next example. So w with a redirection slash temp slash w.log. If I do cat slash temp slash w.log, w.log. So this one just displays the output. This one just redirects output. But if I do w and then pipe and then t and then temp slash w2.log, w2.log. Now what does it displays output to me on the screen, and at the same time it directs output. Temp slash w2.log. There you go. See the difference between redirection and the t command, right? So let's go to the next one. So here they talk about VI editor here, which we already discussed. So let me give you a small task to do right here. We can do this right now and show me. What else we talk about? Sort. There you go. Let's do these 6 questions and in 10 minutes and show me, okay? Everyone. Hey, Teja, are you doing it well? Teja? You have any doubts? Teja, are you there? Okay, good.
లేలే నేను తర్వాత చేస్తాను ఇంకా ప్రస్తుతానికి.
Hey, Sandeep, how are you?
సరే చేస్తాను. నాకు ఒక ఆన్లైన్ ట్రేడింగ్ ఉంది, తర్వాత చేస్తాను.
Hey, Sandeep, can you hear me?
ఆన్లైన్ ట్రేడింగ్ ఉంది, తర్వాత చేస్తాను. సరేనా?
Okay, Chirag, the problem is the quotes should not end with Dallas, right? So only one double quote within Dallas and Atlanta. So the first command is right. Yes, that'll work. Yep, that's correct. So that is not working because of the case. Try to put a -I option. Oh no, egrep. That only works with egrep, right? So only egrep is used to like grep 2 things in the same command. So egrep is going to work. There you go. So now use the -I option to see if it's placed without the case. Grep -I and then the exact same output. Right. There you go. So that displays both Atlanta and it didn't display Dallas. DALLAS, DALLAS. There's type spelling mistake with Dallas. There you go. That's it. So it displays both Atlanta and Dallas at the same output. The command to copy, you mean copy in editor, YY and P, right? YY to basically yank and P to paste. So if you want to copy all the lines, you have to do 5 YY and then 10 P will basically paste that line 10 times. That's it. So you have to go to the top and then do 5 YY and then the bottom 10 P. Get it? There you go, 5 lines yanked, it says at the bottom. So if you do 10 P, it pasted 10 times, that is 50 lines, 10 into 5. So now you get a bigger file. So view the output of the more command. Since you copied, do the more, and then view the output in a more command page by page. It will show you the percentage. There you go. So now with space, and it will keep going down slowly with the space. So yeah, enter will basically go very slowly, but space goes page by page. That's it. So you can view any file you want with the space, with the more command basically. Okay, so Chirag, the problem is you have to do a command first. There is W and then pipe and then P, and then that's the way it works. So you do a W first, and then you do a pipe, and then P, and then TMP slash L1 slash L.log. So pipe, W and then pipe, yeah, pipe, and then T, TE, and then space slash temp, TMP, TMP. TMP actually doesn't exist, it's TMP actually, TMP. /l1.log. That's it. Yep, that's how you start. Very good. So Teja, are you done? Teja? No, okay. So I'll give you 5 more minutes. Are you stuck somewhere? Do you need any help? Last one. Okay, good. So let me know once you're done and we will move forward, okay? Okay, so Teja's done. So Rahman, you do it as well? Rahman? Okay, good. So now let's continue. So this is where we finished the VI editor last class there. So any doubts in the VI editor and all these things that we did till now? What have we done till now? Do you have any doubts in that? Any doubts? Let's talk about it right now. You can tell me your doubts and we'll clarify it before we move further. So is everyone good with the basics of Linux? Okay then. So let's continue. So here they basically revised the commands that we already saw. Date command is used to display the date and time of the meeting. And who is used to display who is logged into the box right now. Who am I is used to display who you are logged in as. W is used to display who is doing what in the machine. Man is again like the manual page in the server that is to basically give you the manual page of the command, like who is like what the command does and what are the different options of the command. That is what manual page does. And next is head command. Head command is used to display the top n lines of file. If you put 5 head-5, it will display the top 5 lines. If you put 10, it will display the top 10 lines. And similarly, the tail command is used to display the bottom n lines of the file. If you put tail-t, it will display the bottom 3 lines. If you put tail-10, it will display the 10 lines. PWC is the present working directory. That is used to display the current work directory of in your current machine. So wherever you are, it will display where you are right now. LFNL is used to display the files in the server. LFSL is used to display hidden files. So what are hidden files? Hidden files are all files that start with a dot. That is what is known as hidden files. Right? Hidden files are all the files that start with a dot. So just the LFNL will not display the hidden files, but if you use -al, it will also display the hidden file. That is the difference between LSFNL and LSFNAL. So these are all the different options. ls-l used to display the files like a directory, and -p is used to display the directories ending with a slash, and lsf and ul and al are the same thing. Just display the particular file, individual file. So mkdir is a command used to create the directory. cd is used to change directory. Like you go from one directory to another directory. We use cd to do that. And rmdir is used to delete the directory. So if you have a new directory you want to delete, you can use rmdir. rmdir can only delete empty directories. If the directory is full, what command should I use if the directory is full? Does anyone know? How to delete the directory if the directory is full? Any idea? rf, rm and rf. That is the command. rm-r is the command to do that. No, so Rahman is saying first delete the file. That is good. But if I want to just delete everything, what if there are like 1,000 files inside the directory? I cannot delete 1,000 files. So the easiest way to do is rm-rf and then the directory name and everything gone in a single shot. Right? That is the most easiest way to delete the whole directory in a single shot. Next one is cat command. Cat command is used to display the contents of a file. If I want to display contents of a file, I use cat command to do that. And next one is cp. cp is used to copy files from one directory to another directory, or in the same directory. So you can also copy directories actually with the cp command. With -r, you can copy one directory to another directory. Just with the cp command, you just copy files, right? So next one is ln. ln is a link. Did we talk about the links? Do you remember the links? Ln command. Yes. Soft link. The ln-s command. Do you remember? Does anyone know what is the link? Okay, good. So ln is the command used to create links. It is very similar to the Windows shortcut that we have, right? So you have the physical file in one location. You create the link in another location, so you can access the original file from another location using the link. That is basically what the link does. So mv is a command. What can you do in mv? What are the functions of mv? Does anyone know? One of the most important functions of mv is to do what? Move and move. Okay, mv is move, but what are the next important thing you can do with mv? mv is based on two functions. One is move and one is rename. Rename is the answer to look for, right? Rename. mv is used to move and rename at the same time. You can basically rename a file, you can rename a directory, and you can move, right? So there is no other command to rename a file other than mv. mv is the only command that in Unix used to do that. So next one is rm. Like I told you, rmf and rf is used to like remove a file forcefully, and it's used to like delete the whole file forcefully. That is the use of rm rf command. Right? So here we have lab 4. So do the lab 3 and 4 and send it to me by next class, okay? So now we're going to go to a very important concept in system administration, that is shell scripting. So what is shell scripting? Let's talk about what's basically a shell scripting, what does it do? So a shell script is a program that issues or executes a sequence of Unix commands. So shell script is a program that issues or executes a sequence of Unix commands. So you have a set of Unix commands that you want to execute in order. That is what shell script does, right? So have a set of commands that I want to execute in a sequential order. I will use a shell script to that. So how do you create a shell script? The easiest way to create a shell script is that of the VI editor. So I do VI space the file name, and I start entering the code, and that basically creates a shell script. That's it. So I'm going to create a very basic shell script, very, very simple shell script. This is like the most easiest script. So VI new script, very basic shell script, right? And then echo, enter your name, and then your read statement, read name, and then echo hello $name, welcome to Unix class. So what does this command, what does this script do? So first it echoes out enter name, and then you type the name there, and then it reads the name, whatever you type there, and then hello $name. So this $name is basically replaced by the name that entered in this second line, and then it says hello $name, welcome to Unix class. So let's go ahead and execute this. So how do I execute a script? I can use these two options. First one is either sh/filename or chmod u+x filename. So this u+x is nothing but providing execute permission. So if I just execute this new script without giving any permission, it will not do it. It will be permission denied. It will not execute. It will be permission denied. So to give it permission, I have to do chmod 775 or 700 new script. Right? So this command is used to execute. This command is used to grant execute permission to a script. So now if I execute it, /new script is asking me the name. I'm going to put Teja. Then it says hello Teja, welcome to Unix class. And instead of this name Teja, I can put Chirag. So it will say hello Chirag, welcome to Unix class. So this is basically known as a variable, right? You see the name they enter here is basically known as a variable. I can put Rahman here. So the next output is replace the name with Rahman, right? So this is basically a variable. This keeps changing all the time. So this can be anything, but everything remains constant, right? So this is a very basic shell script that you basically gave execute permission and then you ran. That's it. So this is how you basically execute and create a shell script. So here they talk about shell variables. What are the shell variables? Shell variables are nothing but variables are nothing but something that keeps changing. Right? The variables are nothing but that keep changing all the time. So these are the standard variables that we have in the system. First one is user-defined variables, something that you define. So for example, I can do pet is equal to dog, and then echo dog pet. It will give me dog. If I do pet is equal to cat, and if I do echo $pet, it will say cat. If I do pet is equal to rabbit, and if I do echo $pet, it will display rabbit. So this variable that you define here is basically defined by you. You defined it, right? The system did not define it, but you defined it, and you can change it whenever you want. That is the reason this is known as a user-defined variable, because the user is defining it, right? Next one is environmental variables. Environmental variables are nothing but variables that are defined by the environment, by the system itself. So what are some environmental variables that we already discussed before? Echo $+1, echo $path, echo $shell. I forgot to put dollar. Echo $shell, echo $pwd. These are a few of the environmental variables, right, that are already stored within the system, which we do not touch at all. So these are the default environmental variables in the system, right? And what are the third kind of variables? Third kind of variables are about local variables, right? So local variables are nothing but variables local to a particular shell. So local variables are variables local to a particular shell. So when I use a shell, I might have some variables only in that particular shell. So for that, we call it local variables, right? We will see the things in the script when we do the script. So here they talk about shell, special shell variables. What are special shell variables? Let's look at a couple of them. So let me show you exit status. The first one is exit status of command. So I'm going to show you that right now. So I'm going to do lsfnl, and then do pipe, and do wcfnl. It displays the word count, right? If I want to grep something, I can do grep when. So this command basically greps for the output and it displays the output, right? So what if I want to check whether this command is successful or not? So I check whether this command is successful or not. So all I do is echo $? So if it says 0, that means the command is successful. So instead of when, if I do then, let's see if they have then here. They have then. If I do echo $? It will say 0. This time let me grep for Franklin. Franklin doesn't exist. So what will be the echo $? It will be 1 because it was not successful. And if I grep for kill. It is not there, so it will not be successful. It's 1. What do we do? LSFNL kill star. Oops. LSFNL kill star. It's not there. So what will be the output of this command? It will be 2. There you go. If I do LSFNL, Ben, output except, oh, Ben doesn't exist. Ben star. How about Ben star? Ben 2 is there. So what will be the output of this command? 0. So anything that is not there is not successful, and anything that is there is successful, and will give 0 for the successful one, and it will give 1 or 2 for the non-successful one. Right? So this is the way it works. So any command that is successful has got a echo at a question mark of 0, and any command that is not successful has got an exit status of non-zero. It can be 1 or 2. It can be anything, right? So as far as 0, it is good. It's successful. As far as it's non-zero, it's not successful, right? So this echo question mark is used a lot in scripts. So if you, for example, if you want to like combine 3-4 commands, and the second command has to be executed based on output of the first command, like if successful, then do this. So this is how you basically do it. If you want to execute command number 2, and you only want to execute command number 2, if the output of the first command is successful, then in this case you use this echo question mark. Right? Any doubts in this one? Any doubts in echo question mark? Okay. So no. So why dollar question mark? Dollar question mark is basically the one that is used to display the exit status, right? So to display the exit status, you have to use this one. So this is the one that is used to display the exit status of the previous executed command. So whatever command that you executed previously, it will display the exit status of that command, right? So like I told you, if I have like 4 commands and I want to execute the commands in a sequence, and if I want to execute the second command, only the first command is successful. In that case, I will do this, right? So when it will give 2, so it will give 2 when, because due to this no such file or directory error. So when we have a no such file or directory error, it usually gives 2. And when the blank output, it gives 1. And when that successful output, it will give 0, right? So is that clear? Okay, good. So the next one is echo $. So echo $. Echo $. Let us see what that is. So echo $. is giving a particular number. What is this number? PSFEF grep for 3171. Do you know what this PSFEF command does? Does anyone know what is PSFEF command? PSFEF. Any idea what is PSFEF? Did we talk about it? PSFEF? Yes, no?
Current running process.
No. Process, right. So PSFEF is to display the process in the system. So if you open Windows and you open Task Manager, right? So the Task Manager is used to give all your processes in the system. So the process number and basically your comments and everything is displayed here, right? So the equivalent command in Unix is basically the PSFEF command. So let me show you here. I lost control of the. Okay, let me see. I cannot control your desktop anymore. You have. Can you minimize that? Yeah. Okay. Let me see if I can control now. Okay, now I can control. So PSFEF is the command used to display the process information. So let me show you here. So PSFEF 5 for more. So here, if you see at the top, it displays the process information. So first it displays the UID, what user account is using, then what user account is using that process, then it displays the process ID. What is the process ID? Process ID is nothing but it's a unique ID assigned to a particular process. What is a process? A process is nothing but it's like an application that's running the system. So in the task manager I showed you, it's a lot of process, right? You saw a process for Word, for VirtualBox, for Notepad, for Chrome. Everything has got a process, right? So even in Unix, everything that you execute has got a process, and every process has got a unique number. So init has got a process of 1, PID of 1, and netNS has got a process of PID of 10, and it keeps changing. This is not constant. This will keep changing all the time. So this is got PID of 1, and what is the parent PID? Parent PID is something but what PID owns it. Like this is the child and this is the parent. So every process in Unix has to have a parent, right? If it doesn't have a parent, it is known as a zombie process. So you have to make sure that every process has got a parent process. If it doesn't have a parent process, it becomes a zombie process. So PID is something but the process ID. PPID is something but the parent process ID, right? And then C is something about the count. STime is something about the start time. Where did the process start? TTY is something about the terminal. And time looks like this, like how much time the process has been idle since. So whatever time the system has been idle since, it displays the time. And CMD means command that it's currently executing right now, right? So if someone is asking you, can you please tell me what processes this application is using? So for example, there might be an application called SSH. So I'm asking you, can you please tell me what process ID is SSH using? You tell him sure. So then you do PSFEF and then pipe grep SSH, and then it will display the process ID here, 1208. See that? This 1208 is something but the process ID of SSH. That's it. Right? So this 1208 is nothing but the process ID of SSH. And tomorrow someone is saying that can you please kill it? So all you do is kill -9 and then the process ID name. Done. So that will basically terminate the process and it will kill it. That's the command to kill process. Right? So for now, let us focus on the echo $. So echo $$ gives 3171. What is 3171? PSNEF grep 3171. So what is this process? This process, the bash process, right? So what happens if I kill it? Can I kill the 3171? What happens if I kill it? Let's watch what happens when I kill it. I'm going to hit enter now. Just watch the screen. There you go. The shell vanished. Why did it vanish? Because there's the process number of the current shell that I was logged in, right? So I was using the shell, the bash shell. So the bash has got a process. So basically what I did is I killed my current shell. Then what is the echo $$ used for? Right? You get it? Open the putty again. $0.10. So now, if I do echo $, echo $, give me a different process, 3464. If I do PSNEF, grep 3464, it'll display the process of my current shell, 3464. See that? And this PSFNEF command is created by the shell. So that is the reason the parent process of PSFNEF is something but 3464. That is the process of the shell. See the relation between this? So whatever command execute here, we have the bash as the parent process. Right? You get it what I'm saying? So whatever command that we execute here, we have bash as the parent process. That's it. So this is how the process works in Unix. Any doubts? Any doubts in this one? Echo $, question mark? Why 3487 and 3488 show? 3487 and 3488. So 3487 and 3488 is nothing but PSFNEF is the first process, and grep is the second process, right? So PSFNEF is the command that I execute right here. This is created by the shell, bash the shell, 3464, and this has got a parent process of 3464, and this has got a parent process of 3464. So when I grep for 3464, it shows the original process and the process that had the parent as 3464. Right? Did you get the concept what I said? The parent process. Just because 3464 is the parent of two other process, it displays that as well. Simple. Get it now? Is it clear, Ramon? Okay. Good. So let's go to the features offered by the shell. What are the features offered by the shell? So first one is the hash symbol. Hash is something about the comment. Comment is something that is ignored upon execution. Let us see example. So vi space the script, new script that we had. So if I put a comment here, if I put a comment here, and I put a comment here, will the script work? New script, it will not do anything because everything is commented. So now if I just remove if I just remove the comment from the first line, it only works the first line, right? You want to see anything without the parent process? So show anything without the parent process. No, everything has got a parent process. You can't. The only way to see that is if you grep for the zombie process, right? So only if you have zombie process, only a zombie process doesn't have a parent. Apart from zombie process, every other process has got a parent process, right? So that is the way it works. Every process has got a parent process, and zombie process is the only one that doesn't have a parent process. So we cannot see a process without its parent process unless it's a zombie process, right? Does that answer your question, Teja? Okay, good. So let's continue. So comment, I was talking about the comment is nothing but the hash. So the way this works is, if you put a hash in front of the line, it completely ignores it. The line completely is ignored by the script. It doesn't consider it at all. So if you remove the hash, you can basically, the script considers it and it starts executing it. So what is the function of this hash? So this hash is used to add a small note to the users of what the script does. So when you write a script, you can add a short description in every line of the script, like what the script does. And that will be exactly, that will be completely ignored by your script, right? So that is the whole purpose of using the hash. Get it? So let's see a little more further. So what are other things they have? One is the escape mechanism. What is the escape mechanism? So for example, echo the symbol multiplies star. So this works this works good without any issues with the quotes. But what if I remove the quotes? What if I remove quotes and if I hit enter now? So why does it do that? Say symbol of multiplications. What are all these things? Any guesses? Why does it display all these things here? Dar as DR, diary. I just gave the symbol of multiplication star. That's it. Instead of star, it displayed everything right there. What's that? Does anyone know? Any clues? Any ideas? What is that? What are all these files?
Current file in the directory.
Correct. Current files on the directory. Exactly. So the reason it did that is because star is a wildcard, right? So star is basically a wildcard that is used to display your current files. So for lsfnl star, it displays everything, right? ls star displays everything, right? So all those files are basically displayed here. So how do I get rid of this? How to use the escape mechanism? What if I do this one? There you go. So this escape mechanism is used to tell Unix to consider star as star. Don't consider it a wildcard. Like consider star as a star instead of wildcard. That's it. So if you don't use the star without the quotes, it will display the current files in the directory without anything because it considers star as wildcard. But if you use this escape mechanism, it basically tells Unix to ignore the wildcard and just consider star as a star. Get it? Is this clear? Is the concept clear? Doubts here? Okay. So the last one is command substitution. What is command substitution? So if I do echo date, it just displays the date just like that. So what if I want to display date? Echo date, single quotes date. This also doesn't do it. So I use the quotes next to the shift, next to the enter, didn't work. Let me try using single quotes next to the tab, above the tab, and let's see if it works. So there you go. So now it displays the actual date. So I use the quotes below the escape key on the keyboard, and now it displays the value of date, but not the word date, right? So when you use the single quotes date, it displays the actual value of date instead of the date. Let me replace the date with any other command like who. Echo who. Displays who's logged in. If I use echo w, who am I? Who am I? It will display the value of the who am I. It will execute the command who am I and list out. That's it, right? So this particular thing is known as command substitution. This is known as command substitution, right? So we talked about this the hash escape mechanism. We talked about hash is the comment escape mechanism and the command substitution. So what are the other features of the shell? Again, the exit status, like I showed you. The exit command used to exit the shell script and tell us the exit status of the shell. So 0 means success and 1 means not success. How the date coming? So the date comes because of echo date enter. So the date comes because it executes the date command, right? Echo date. This executes the date command. That's it. You can execute any command you want like this, right? So this single quote I use is the one above the tab on your keyboard. What is it? Auto. What is it? What do you mean auto, Rama? I don't understand that. What is auto? What do you mean the auto? So it's not automatic. I entered manually. I entered the command manually, right? And I tell Unix to basically consider means date is coming out. So because I execute the date command, so I tell echo to execute the output of the command rather than just doing echo the date, right? So if you do echo date, it will just display the word date out. That's it. Echo date will just display the word date. But if I want to execute the output of the date command, I will use this one. Right? You get that? So there is a difference between this command and this command. There is a difference between this command and this command. This command just displays the word date. This command displays the command date. Because date is a command, right? Date is a command in Unix. Get that? So this basically is executing this date here. Instead of date, it can be any command you want. mkdir, s, wcfnl, w, any command you want. Right? So we already saw the exit status. So let's continue further. So here they talk about numerical comparisons. So what is numerical comparisons? Numerical comparisons used to compare two different numbers, whether they're equal or not. Integers, basically. So $n1 -eq or n2 will basically check if two integers are there is integers n1 n2 are equal or not, right? So -any means it will check whether two variables n1 n2 are not equal or not. -gt means it will check whether n1 is greater than n2. -lt means it will check whether n1 is less than n2. -g means it will check whether n1 is greater than or equal to n2. And -n1 le means it will check whether n1 is less than or equal to n2, right? So eq means equal, ne means not equal, g means greater than, lt means less than, g means greater than equal to, le means less than equal to, right? This is basically comparison operators in Unix that we use to compare two integers, right? And next we talk about negation and an OR. So negation is like exactly do the opposite of what the command is supposed to do. The command is supposed to do something. You exactly do the opposite of the command. That is what is known as negation, right? So an A and operator and an OR. Does anyone know what is AND and OR? Do you know what is AND and OR? You studied in your college and schools, right? So do you know what is AND and OR? Does anyone know what is AND and OR?
And is satisfying both the conditions or is either of the condition?
Very good. So AND is basically satisfying both the conditions. So the command has to be successful. The first command has to be successful, and then the second command will be successful. So OR doesn't care. Either one of them has to be successful, and it'll just give you the output, right? So the second command is executed only if the first command is successful in the case of AND. In the case of OR, it just needs one of them, either of them to be successful. That's it. So we're going to see all things in examples actually. Then you'll understand very clearly. So here we talk about features of arithmetic operations. So how do you do arithmetic operations? Let's see a couple of them. So in Unix we have a command called expr. Expr is a command that is used to do multiplication. So expr 6 plus 4, 10. Expr 6 minus 4, 2. Expr 6 divided by 4. There you go. That's a problem right there because it doesn't give you decimal. So it always rounds it up to nearest integer. If I do expr 12 divided by 4, it will give me 3. How do you multiply? Star 4. It doesn't work. Why multiplication doesn't work? What should I do here? Any idea? What should I do to make the multiplication work here? Multiplication doesn't work. You have to apply the concept that we did in the previous, in the few slides back. What is the concept? There you go. Very good. There is the answer right there. You have to do the escape mechanism. That will work. The other way around. This one. There you go. 48. So 12 into 4, you have to use the escape mechanism, and it will show the value of 12 into 4. Right? So this is how all arithmetic calculations are done in Unix with the help of expr command. expr. expr command is to add, multiply, divide, subtract two numbers. Right? So let's see an example of AND and OR command right here. I'm going to see this example here. Okay. So what this command does is let us execute this command first. This is a command using AND operator. So what it does is it greps for the word good in a file called gems and displays pattern form. So only if this command is successful, we go here. So let me get a file called gems and then add a word called good and then save it. So now if I grep it here, it says good, it found good, and then pattern found. What if I remove the word good from it? What happens? If I save it, and now if I do grep good gems, no output. So it doesn't even reach here. It doesn't even reach state. Why? Because this one is not successful, right? So now instead of this, I'm going to do this command with the OR. I'm going to paste this here. Now it says pattern not found. Good gems. So this, since it did not find this thing, it says pattern not found. So what if I add the pattern here? And execute the OR operator. So just execute the first command and it stops. That's it. So since it does not need the second one, it just stops with the first one, right? So the way AND works, it needs both these conditions satisfied. The way OR works is just one of them, either this or this. If this is not true, it executes can one. That's it. So is this clear doubts here? No? So let's do a very simple program to add two numbers, okay? We add, since we know all the concepts, I'm going to show you a very simple program to add two numbers right now. Echo, enter first number, read num1, echo, enter second number, read num2. Now how do I add it now? What is the logic? What is the concept I use to add two numbers here? Any idea? So what I can do is echo. There you go. Excellent. Echo number 1 plus number 2. There's one way of doing it, or I can use the echo sum is. Can I use the expr command to do that? So what I can do is sum is equal to expr dollar num1 plus dollar num2, right? And then echo sum is dollar sum. That's it. Will this work? Will this work? Let's try. Let's get a shot. Right? So chmod 755 add /add, and then I execute it. First number is 4. Second number is 3. There's a problem. What is the problem? No such file directory. So there's a problem. There's a big problem. So let's see what it is. The problem is, let's remove space and let's execute it again. 4, 3. So again, there's a problem. 4 command not found. Line 5 command not found. So it's line for 1, 2, 3, 4, 5. There's something wrong with this one. So let's remove the expr and see if it works without the expr.
Maybe you need to put it in backwards.
Right. So now it doesn't find the plus. So let's try this one. So let's try to put expr someone present to right here and see if it works. This might have to be backwards. There you go. It worked. So that is the way to add two numbers, right? So this line is not needed. This line is not needed. All you need is to use the expr command, $num1 plus $num2, and then added the two numbers, right? So why don't you go ahead and write a script? Let me put it right at the bottom. Why don't you go ahead and do these two things right now? Subtract and multiply two numbers, same thing. Get the output, get the input from the user, and just subtract and multiply. Two scripts, okay? Okay, Chirag, so you have a problem there. So the first of all, there has to be a space between the minus and the numbers, and you can also have like a that's the main problem right there. Escape and Z, escape and ZZ. Yep, that's it. Excellent. That's it. So that's how we subtract two numbers. So now go ahead and multiply. What you can do is you just copy the script. You can cp sub to mul and then vi mul and change the symbol. Done. So cp sub to mul. cp sub to mul. No, don't put the two. Just cp sub mul. The copy command that we discussed, right? So mul, enter. So now vi mul. Hit enter there. Hit enter. Then vi mul, and then start editing. That's it. That's the multiplier. Done. So that's how you basically shorten your work and do things the smarter way. It's the other slash, right? Yeah. Oops. Escape and it's easy. There you go. So now escape the multiply. Excellent. There you go. That's it. So that's how you do the multiply script. Done. chmod you didn't have to do because you copied from sub. Sub already had the permission. So you copied sub to mul, and mul also got permission. So you didn't have to do the chmod. If you create a new file, then you need the chmod, but without that, you don't need the chmod, right? Okay, good. So is everyone done? Can we go to the next topic? Is everyone done? Who's still doing just with chat? Put the Teja. Are you done, Teja? Okay, no, you're doing okay. We can wait, no problem. So let me once you're done, and we will continue with the next part. Yeah, so the decimal doesn't work. That's the problem, right? So decimal don't work. So okay, the solution there is there's a command called BC. BC is like a calculator. So what you do is 2.3b into 4. There you go. So there is a solution. BC is a solution to basically do it. So you can also divide anything you want. So 5 divided by 2 will give you the hold on, that didn't work. So it looks like you have to basically set the decimal symbols that you want to see. Let me check that. Hold on. They call the value. So we have set the number of digits after decimal point. Let me see how to do that. They call it scale too. So let's execute this this particular command. So if I type, so let's do Control C, echo scale is equal to 2, and then 100/3 close the quotes and then BC. So this command is going to execute the decimal with 2 points. If you add more, if you put scale 3 or scale 4, it'll give you more decimal points as you want, right? So this 100 divided by 3 can be 100 anything, multiplied by or divided by, subtract, right? If you put 6, it'll show you 6 decimal points. So there is a solution to overcome this thing, right? So is that clear, Chirag? Okay, good. That's a good question. So Teja, are you still doing it, the multiplication? BC can be used in VI the same way, right? The echoing that I showed. Yeah, sure. You can be using a script as well. So same thing. You can use the same command, but inside the script, and that is the same thing, right? This can be used within the VI in the script as well. So it's about the same way. So let's continue. Page is done. Let's continue. So let's go with the next thing, like feature, some of the language constructs. This, you might already come across these things when you must be doing like your C programming or Java or other things, right? So let us see with some of these constructs. So what is if statement? If statement is a very good statement, right? So all it does is, if check the condition, then do something, else do something, and then done. That's it. It's a very simple thing. If the condition is true, then do something, else do something else, and then done. Simple. So let us look at this example right here they have. So Control C. So VI, oops, Control Z. So VI this one, VI if, and then I put the whole thing here. So what is dev null? What is dev null here? Dev null is like if there's any error in this particular command, like command not found or no such file or directory, what it does is do not show me that error on the screen, but just put it in the garbage. So this dev null is used for garbage collection, like just take it and put it in the garbage, do not show on the screen. That is the use of the dev null, right? So let me execute this thing right here. So grep read text. We need a file called text, and we need a word called read inside it. So now if I execute, oops. So now if I execute this one, /text, okay, I need to give the chmod. Chmod 755 text. Okay, the script is in if. I'm executing text, supposed to be if. Chmod 755 if, and then execute if. So it says pattern found. Why does it say pattern found? Because it did grep read text and it found the pattern. So let me remove this word. Let me delete this word, okay? And then if I save it, pattern not found. That's it. Right? So all it does is it checks for a condition, and then basically executes a thing, else it executes something else. So if it finds a pattern, then it executes this one, else it executes this one, and then the way to close the if loop is with this thing, right? This is the way to close the if loop. That's it. So is this clear? Any doubts here? Okay, let's continue then. No doubts means. This is the same script that we saw here. So all it does is it's got two patterns, so two conditions actually. If, then pattern on, else if grep passage. So we need files for this one. We need a file called text and we need a file called passage. Right? So text, it checks for read in text and it also checks for read passage. So there's two conditions. So it has to satisfy the first condition and satisfy the second condition as well. Right? So we're going to go ahead and do this script. So one important thing I want to tell you here is this first line, shebang. This is known as shebang, right? So what is shebang? Shebang is a way to tell what shell to use when executing script. So if you put KSH, it will execute the script in KSH shell. If you put CSH, it will execute the script in CSH. If you put bash, it will execute the script with bash shell's capabilities. Because each and every shell has got their own capabilities. If you want to utilize the different shells capabilities, you use the appropriate shell here, right? So that is the use of using the shebang at the top, the shebang. So even you might ask me, hey, it's got a hash in front of it, that means it's a comment. But look closely in the next character, it's got this negation operation. So this negation operation that you see that is used to exactly do opposite of what the comment does. That means consider it, right? So the comment says, do not consider anything after this, but the negation operation says that consider it, right? And then it considers bin bash, right? So this is a very important line. It's known as shebang, and it's used almost all the shell scripts, right? So go ahead and execute this script right now. You have to create a file called text. You have to create a file called passage and add read in them and try to see if it works, right? So go ahead and execute the script right now. Shebang, yeah, you can put the shebang. You can also put the shebang in the front. It's good to use the shebang. There is a hash. It has to be always in the beginning of the script, first line, always in the first line. Right, /in/bash. So should I see used to capital I? That's not going to work. It has to be small I. If right, you say if. It has to be small if. Capital is not going to work. Right. Because Unix is case sensitive. It needs everything in the proper way to work. So /bin/bash. There is a location for the bash shell. And then execute it. So did you create the passage and the text? You can try to like see what happens when you don't have those files, and you can try to see what happens when you have files, and you can also try to remove the pattern and see what it says, right? There you go, pattern found text. So now what you do is you put a line, you put a file called passage, and you put the word there, and then you try to execute it. So create a file called passage. and then you put the word there. Is it text? No, you have to put the exact word that it's looking for, because it's a read. You have to put read, and read is what it's looking for. So put read, because it's grepping for read, right? It's grepping for read in both of files. So put read and then save and run it. It's looking for read in text and looking for read in passage. So execute the script and see what it shows. Yeah, there you go, executed. That's found in text. So how about the passage? You added the passage, right? So now what you do is remove it from the text and see if it goes to passage. Remove the pattern from the text file. So vi text, and then remove the word called read and execute. See if it goes to the passage and shows the passage. Right, hit enter, deleted, and then dd, and then yeah, you can do dd. That is easier. Okay, now save it. It's an empty file and execute the elif. Right, and then okay, pattern found in passage. Good. So since we did not find in text, it jumped to the passage. So now remove it from passage as well, and you'll see what shows. Remove the pattern from passage as well. dd. Then you execute it. Yeah, escape and dd. Right, there you go. dd is the command to delete the whole line. Now we execute it, and now it will say pattern not found either. There you go. That's the last condition. So that's it. Right? Okay, so is everyone done this? Is anyone still doing this script? The A script, is anyone still doing the A script? No? Yes? Okay, looks like everyone is done then. Let's go to the next one. Next one is a case statement. So what is a case statement? Case statement is, go to the next one. Okay. So the case statement is very important statement. So the case statement is basically used like a menu, right? So you have a menu, you have a list of commands, and you present those commands to user like choices. You can say choice 1, choice 2, 3, 4, 5, etc. Right? So you have those choices, and you present those choices to the user, and the user gets to pick one of them. That's it. So you give like 4 choices, and user picks one of those choices, and you basically picks one, and then you execute command based on the choice. That is what is a case statement. So let us see an example what the case statement does. So what I do is, let me type here. Let me type this here. So vi case. I'm going to put my own script. I'm going to copy that. I'm going to put my own script. So you must use the shebang dash, and then echo, enter one of the, okay, and then echo one dot, enter, no, there's no directory, echo 2 dot, today's date, and echo 3 dot, number of files in the directory. That's it. And then I have to put a comment here. So I will put the case statement right here after this. So at the top, let me again let me put one. Enter your choice, and then read the choice. Read choice. Okay, should be a C. Read choice, and then now you open case statement. Case dollar choice in, and if he types 1, what do? You do PWD. And if it types 2, what do? You put today's date. This thing is important at the end for the case statements. Keep it that way. And if you enter 3, number of files current directory ls-l 5 wcl, close this one, and then anything else other than 1, 2, 3, echo invalid charge. That's it. Alright? This is a very basic case statement. Let us see if it works. So once I'm going to ask these questions, you have to either enter 1, 3. If you enter anything other than 1, 2, this is invalid choice. So chmod 155 case dot dash case. Enter your choice type grid 2. There you go, done. If I give 1, root current working directory. If I give 3, 50. 50 is the number of lines in the file. What if I give 7? Invalid choice. That's it. That's how the case statement works. Right? So go ahead and do this. Go ahead and do this exact script that you see here in the screen. Only difference is change this csh to bash. Instead of ksh, it has to be bin/bash. That's it. So go ahead and execute the script right now. So any doubts on this case, how the case is working? Any doubts? Feel free to ask me right now. Any doubts here? If not, go ahead and do this case statement right now and show me. Okay. Okay, good. So it looks like it's done. Excellent. So is everyone done? Teja and Rahman, are you guys done? Are you still doing it? So any doubts? Okay, you just see what? What do you see, Rahman? Okay, no. So Teja, how about you, Teja? Are you still doing it? Done, excellent. So let's continue that. Let's go to the for statement next, right? So what is a for statement? For loop. The for condition is used to perform the same operations on a given set of values. So let me show you a very simple example, right? So for I in 1, 2, 3, 4, 5, do echo $I, done. So what it'll do is display 1, 2, 3, 4, 5. This is a very basic example of a for statement. So let me put this in a script, vi for, and I put the shebang, and I put for I in 1, 2, 3, 4, 5, 6, do expr $I. Oops, there is a small problem here. $I. There you go. So all it did is it basically gave me square root of the number, right? So for I 1, 2, 3, 4, 5, it did expression $I into $I means square root of the number and done. That's it. So the way for loop works is you give it a range. So this I is basically a variable, and you tell it for 6 i's, you do this one. So I 6 times, and you do expression $I. There is 1 into 1, 2 into 2, 3 into 3, 4 into 4, 5 into 5, 6 into 6. Done. So it's going to multiply all these numbers with each other 6 times, and it's going to do it. Right? So 1 into 1 is 1, 2 into 2 is 2, 3, 4, 5, 6. So instead of this, you can do plus or whatever you want. Right? Let me show you that. So instead of this one, star, you can also do plus. It'll just add these two numbers. That's it. Right? So you can see the application for for. So the for can be used. It doesn't have to be this command. Instead of this command, it can be anything. For example, create directories, create files, touch a file, delete file, search for something. So with this concept, you can apply this for anywhere you want, right? That is the whole thing behind the way for loop works. You have to know the concept, how it works, and you can basically apply it with any condition, right? So let us see what is the example that they have here. There you go. This is the exact command they have, the square root, right? They have the square root here. So go ahead and do this command right now. Go ahead and do this script right now and show me the for script. Okay, good. So is everyone done with the for loop? Is anyone still doing it? Okay, let's continue then. So next, go to the while loop. What is a while loop? So while, the way while works is like while some condition, do something, and then done. That's it. So while you give a condition, while it's true, so the while is also known as while true. So while the condition is true, you basically do something, and then done. So let us see an example of the while loop. So here it talks about the pattern found. So for this, I need two windows actually. Let me duplicate this session. Duplicate session. Root. Oops. Yeah, go ahead and paste it. Yep. Okay, good. So let me put the script here. Let me put this while script here. So vi while. So all it does is basically, let me remove the exit command. I'm going to show you what the exit does. So exit is used to exit the loop, but I'm going to remove the exit and grep Tom names. So all it needs is, it needs to get for this word called Tom in names. So let's do that right here. Vi in names. I'm going to put add a word called Tom. Okay. And chmod 755 while and run it. Oops, the syntax error. Line 4 and 7. What is the problem? Here there's a problem somewhere. While true, do, done. Let's delete this and manually. Echo pattern found, and then let's do it again. There you go. Line 4 echo echo. What did I type properly? Oops. Echo. Let's see if it works. Take 3. There you go. So this works, right? So look at what happens when so this screen is going on the right hand side. Look at what happens when I remove this vi this file names. I remove this word called Tom, and then I save this file. Shift Z. There you go. So this stopped immediately right there. As soon as the pattern was not found, it basically stopped right there. So what happens when I run it again? If I run it just like that, it will not do anything. But if I add the word called Tom, oops, and then I run it, and then if I basically do this one, then it'll keep running, right? And when will it stop? It will stop only when the condition is false. So till this file got names, it'll keep doing it. So as soon as the name is removed, it's gone. That's it. You see the difference here? So the while true condition only works till the condition is true. As soon as the condition becomes false, the loop stops. It's basically a loop. It keeps doing it, right? So whatever command you execute within the while loop, it'll keep doing that forever until the condition is false, right? So that is the whole concept behind while true. So go ahead and execute the script right now, this while true script. Do in the same way that I open two windows, you can basically analyze the output with the Tom and names. And once you put the word Tom inside names, you'll see the difference, right? So go ahead and do this right now. There's a problem. So what you have to do is, the problem is with the echo, delete that line, because sometimes when copy pasting, it doesn't work. So vi the file and delete that echo and type it back again, right? So you see the echo, yeah, delete the whole line and type it manually. You can use dd to delete. Okay, that's good as well. Do. Oh, there's a problem. Do. Okay. Not found. Yep, that's good. So now execute it, and hopefully it should work this time. Again, line 4 and line 7. We are while to go inside again. It looks like you see not failure of the changes. You see that? You didn't type that, right? This was you put not found, but still has pattern found. So it did not save the changes. So dd the whole line, and then start typing echo not found or something, whatever you put before. Public quotes. All right, save it WQ or ZZ. ZZ, capital ZZ 2 times. Shit. Okay. So now cat the file. Cat the file. Yeah, add it and check if it's there. Not from, okay, now execute it. /while2. There you go. So now that works, right? So now on the left hand side, you go ahead and remove that entry from there. So make the condition false, and now it'll not work. DD the whole thing basically. DD. Okay, that'll also work. You can put something else, doesn't matter, and then save it. Some of the pattern, and then go to the right side. You'll see it stopped. That's it. All right. That's it. So that's how you basically execute the while true. Right. So now, so is everyone done? Is anyone still doing it? While true. Teja, are you still doing it? Teja, done? Okay, good. So next one is until false. Until false exactly is the same as while true, right? Until false is exactly the same as while true. The only difference is while true does until the condition is true. Until false keeps doing it until the condition is false. So as soon as the condition becomes true, the until stops, right? So while true is something the condition is true. Until false is until the condition is false. So let me show you. Let's execute this right now. Control C, and I basically write this code here. Oops. So let me do this here, right? So vi until, I'm gonna paste this code here. So until ls pipe grep red. So what it does is it basically does ls and it gets for a file called red. And if it finds, okay, this exit is used to exit it immediately. I'm going to delete the exit here, and let's see what it does. So the way it works is if it doesn't find it, it will say file not found. But as soon as it finds it, it exits out of it, right? So this until false works until the condition is false. Let me show you right now. chmod 777. File not found. But look at what happens as soon as I create the file in the other window. Right? So what I'm going to do is I'm going to create the file here, touch red. Touch red. So look, see what happens. I haven't done that yet. So as soon as I hit enter here, this will stop. There you go. It stopped. The script stopped, saying that it cannot continue anymore. So when you run it again, it'll give the same error. That's the end of file, looking for matching. So since it found the pattern, it's just an unexpected end of file. So that's how the script ends actually. So now if I basically, if I delete this file, rm red, and I execute again, it'll keep going again, right? See that? Forever. It'll go on forever until you basically touch it here. If I do touch red, it stopped right there, right? So go ahead and do this right now. Go ahead and do this until script right now. No, it's basically a file called red. It has to just be a file. It doesn't look for the content of it. It just has to be like a blank file inside the directory. Because the condition is ls and then pipe and then grep for red. So as it can find the file red, it's good. So you have to have the condition there, right? So all you need is a blank file with red. That's it. Doesn't matter what content is inside it. Until 2. Oh, there's a problem. What is the cat the until 2 and see what is inside it? So file ls5 grep red. So you have to basically delete the file red. And did you do it with delete the file red? Did it work? So delete the file and try it again and see if it works. rm red. Right. And then execute it on the other window and see if it works. Yep. Still doesn't work. Why? Let me check. ls5 grep red. Is there any red here? Oh, there's a red here. Where did it come from? So now execute it. It looks like now the red is gone. right? So now execute it, the other window. Execute the script in the other window. File not found. Okay, so the reason it's doing that is because I told you the exit command, right? So the reason it's only doing it once and not doing the loop is because of one command here. Oops. vi until 2. Until 2. So the reason that is because of the exit command. You see this exit command here? Let me comment it. Now see what happens. Now execute it. You'll see the difference. Now go ahead and execute this until 2 again. Yep, that's it. So the reason I was just doing once and coming out is because of that exit command that you were seeing there. Right? That is the whole reason. So now when you remove the exit, it just executes the whole loop just like that. Right? Did you get the concept? Did you get the concept of the until false? See, once you know shell scripting, it's very easy to know other kinds of scripts like Python, like Perl. So the whole concept of shell scripting is very important to learn other scripts. So we'll be learning the scripts later on, like towards the end of the course. We'll be learning Python, Perl, so Ruby as well. So if you know one, you can easily say that, oh, I know the others. I know the concept and I can work on the others, right? So they all work the same kind of concept. The syntax is different, but when you know the basics of it, it's very easy to learn, right? So let's continue. So next we go to test operator, test command. So the test command is used to basically test if two strings are equal or not. That is the use of the test command, right? So if this square bracket is the test command, basically. You see the square bracket here? So the square bracket is the one that is actually the test command. So let me execute this right here. Test command is statement, right? So vi test, and then I paste it here. So there are two things basically. So I have to delete the first one because I just have to use this one or the other one. So I'm just going to use this one. So let's read what the script does. First, echo what is the greatest OS, and then read the answer. And if the answer matches either with this or with this, using the OR statement, then it says your Unix thread. Else, please try again. Right? So test is a directory. So I have to basically save it with test1. Test1 new file. So there you go. Now, oops. So new file called test1. So cat test1, I have all the contents here. So chmod 755 test1 /test1. So what is it? Guess what? If I put Windows, it will say please try again. If I put Unix, it will tell me Unix deleted. If I put capital Unix, it will tell the same thing, right? If I put small Unix, it will say the same thing. That's it. So that is basically how it works, right? Test1 actually, test1. But you get the concept. This is the main line that you want to focus on. If the square bracket is basically the test operator used to see if a string is equal to the answer or not. So if $answer is equal to Unix, that means it checks whether this answer you entered is equal to capital Unix, or it's equal to the small Unix, or it's equal to the small Unix, right? So instead of -o, it can keep going. Again, you can add -o and then add Linux -o. You can add C. Let me show you that. So vi test1, and then I go to the end here, and I do -o, $ans equal to Linux -o, $ans equal to small Linux. So now if I save it, if I do test one, and if I type Linux, oh, there's a problem here. Did I put, I close it properly here? No Linux, Linux. But there should be a space at the end. That's a problem. There you go. That's the issue there. So let me try again. Linux. There you go. You are Linux literate. If I type capital Linux, it'll work, right? So instead of that, you can keep adding any conditions you want, right? So you get the idea of the test operator. Test operator can be like used to compare and test whether the string is equal or not. Instead of -o, you can also use -a. -a is for and, -o is for or, right? So go ahead and do this script right now. Go ahead and execute this test operator script right now. So here, yeah, you are using one of them, correct? That's it. So you're missing, yeah, okay, that's another way of doing it, correct? That's good. So you can either use the square bracket or you can use the word test. Both do the same thing. That's good. That'll work. Yes, that's it. No, Windows is a Unix literate. Good. Okay, good. So is everyone done? Is everyone done with this? Is anyone still doing it? Is anybody still doing the script right now? No, yes? Okay. So let's continue then, right? So these three, there are three examples that I want you to do as homework. So 71, 72, 73 are basically homework. I'm going to write here on this notepad. So do this at home and send me basically a screenshot, right, that you executed these scripts successfully, right? So I want to see a screenshot of these scripts and the lab as well. Whatever lab is there, you have to basically send me the lab as well, because that is very important. See, the way Unix works is the more you practice, the more you get it. If you don't practice, you will not get it. You'll go to the company and you'll be like, oh, what is this? I don't remember. So when you do it practically, then remember that this is how it's done, right? That is very, very important. So let's continue with the next shell programming part 2. So what do they have here? Here they talk about additional features of the shell. They talk about programming constructs again, and they talk about background processing. So let's see here, what do they have here? So they talk about the set command here. So set and the sh commands. So what is the use of these commands here? Let me show you. So one of the most important functions is basically debugging the script, right? So we have a script called cat if, and we have the cat case. So if you want to debug this case statement, what exactly is happening in the background, so tomorrow you might encounter some error with the script, you want to debug it more, all you do is bash -x and then /case. So what this does is it's going to execute the script in a verbose mode, and it's going to give you a more detailed output of what exactly it's doing. Right? So right now, if you see here, it executes the echo statement that it showed, and then it executes echo, and then it executes the echo. F3 and working directory, and it again gives you the output. So if you see here, it tells you what command it's actually doing at the back, right? So this you don't get it with just by doing the bash -x. If I just do /case, it doesn't tell you what line it's executing. It doesn't tell you anything. All it does is the echo statement. It gives you on the screen and done. But here, it tells you at the back that it's executing the echo statement, and it gives you all these things, right? So this is the whole purpose of doing the -x, to give it in the verbose mode. -x is basically used to display the script in the verbose mode, all right? So same thing with -v as well. -v will also display the script in the verbose mode. So let me show you the -v. I cannot control it. Looks like. Is it? No. Okay, now let me try. Okay, now it works. So instead of -x, if I use the -v, it'll do the same thing, right? But it'll give me the more detailed output. So if you see here echo, so here it shows me the exact script and it shows me the output as well. So the read choice is the command that is executing in the background. And I'm going to put choice here 1, and then it'll basically show the whole script of the back case choice 1. It'll show the exact command, and then it'll execute. So you can see the -v is a very much verbose command used to debug a script. So imagine if there's an error in the script, and you want to see what line is it executing right now during the error. So you can very easily see that error with the help of this bash -v command. So this is used to troubleshoot or debug the script of what is going on at the back, right? So let me show you. Let me put a small error here. Let me introduce error, and then we will basically see. So what we can do is we can basically, let's try to remove this 2 things we have, and let's execute it. /case error 2. That's a problem. So because it could not find the 2 semicolons at the end, let's do bash -v /case. So if I do 2 here, so you can say that it exactly shows you what it's doing, and then it gives you the error, right? See that? So what happens when I do the bash -x? 3. So -v gives you like a more better picture than -x, but both do the same thing, right? So -v is also verbose mode, -x also verbose mode, and it exactly tells you where the problem is and what is the problem, right? and then you simply go and go inside the script, and then you add the 2 semicolons, and then you basically fix it. If I do 2, there you go, that executed the date. So now it says case Ryerson, and you enter 2, you hit 2, and it shows the date here, and it executes the date. Okay? So that is basically how you troubleshoot or debug a script, right? Any doubts here? Any doubts in this concept? Any doubts? No, everyone is good. Everyone is clear. Okay. Again? Okay, you want to do it again? So, okay, so when I do bash -x, sure. So when I do bash -x, it shows me where exactly is it executing the script, right? Which line is it executing? So echo, please enter below. It shows echo command, and it shows me the output of the echo command at the same time. And then it shows me the first number 1, and again displays number 1. If I do 2, it executes the command that it's doing, and then it shows me the output of the command as well, right? This is bash -x, but if I do bash -v, it shows me a little less verbose output, but that is also verbose, right? So here, basically, you see it doesn't show you everything that it showed before. So in the previous thing, when you enter 2, it showed you that it's executing the date command, but here it just shows you a case statement, and it shows output, right? So X is good. X is pretty good. X is a little more verbose, and it shows you a lot more information than we. So X is always good to use, right? See that? Okay, good. Is it complete? What is that? Computation? No.
You mean compilation?
Oh, compilation? No, it's not compilation actually. Compilation is like basically compiling a software. This is not compilation, right? This is like just giving you the error of what it's like, verbose of what it's doing, like in a more detailed manner, right? It is giving you the background steps of what the script is doing. You should like debug a script. Like if you have an error, you can see the script line by line of where exactly it's getting stuck, right? Is that Shiran? Yes. Okay, good. So next we talk about shell functions. What is shell function? Shell function is basically a group of commands that you reference from another part of the script, right? So you write like 20 commands in particular a function, and you call those commands in 4 different places in the script, and it will do the work for you, right? So what is the advantage of doing the function? You don't have to type those commands again and again, right? That is the whole use of the function. So let me show you how it works with an example. So vi function, that's the name of the script, and then I start with a shang, and then I basically start typing here. So I'm going to first we have to start with the function. Function always comes to the top. So I'm going to put a function called home like this, and open the bracket, and I can type any command I want. Let's snltr pwd nkd /test touch /temp /Larry, right? So I close the function, right? And then I put echo. Hello, welcome to Unix class. And then I basically do, this is before the function. Okay. Oops, I missed something. Echo. So you can see that this is before the function. The function is not executed yet. So let me put an echo inside the function as well. Echo This is inside the function, right? So I have this function at the top. The function is not executed until I call it. So this is before the function. Let me put this here. PHI. This is before the function, and then what I do is I put another echo, like 4 lines, just to differentiate, and then I close it, and then I call function home. That's it, done. And then I put an echo, and I put this line here just to show you, and then echo end of function, right? And then again I can call function and you'll see the difference, right? So I'm calling the function 2 times. PS mode 755 function. Execute the function. Oh, that's a lot of output. Let me reduce it. Let me remove the ls command. Actually, ls is too much. ls, and let's remove the PWD. Now let's try. You see here, first, welcome to the Unix class. This is before the function. So the function is not executed first. And then I put a line, and then I execute the function, and it goes inside the function, right? And then again call in the function, and again I call the function. So you see that? So function is used to, like, I can call the function any number of times, and I do not have to type those commands again and again, right? So basically, I create a function here with these lines inside it, and I type my code, and I then call the function, and I again call the function at the end. So I can keep calling the function 25 times, 100 times, 1,000 times, right? So the advantage is I don't want to type these 3 lines again and again. All I have to call this home, and I can create 25 functions, any number of functions I want, right? So that is basically the use of having functions in the script. Is the concept of function clear? Who didn't understand? Who didn't understand function? So go ahead and do the function right now, but innovate your own function. You create your own function and basically call it 2 times. Let me see what you can do, right? Go ahead and do your own function and call it 3 times within the script and show me that. Go ahead and do it right now. So Rahman and Teja, can you email me your screenshot with your function? Let me see what you did, right? So after you do it, send me an email with your function and let me see what you can do.
Victor, quick question.
Yes.
Yeah, can we use loops within a function?
You can use, yeah, absolutely, sure. You can use loops in the function. For, while, if, anything. Yep. So looks like Teja's function has got a problem. Command not found. What's that? Can you send me your script, Teja? Can you email me your script? I saw the error, but I don't know what the script does. Why don't you go ahead and email me the script? Right? Let me look at it right now, and I will tell you what's the problem. Okay, this I'm getting Teja script now. Dash home equal this insert function on the touch. Okay, the problem with your script is you see the shang in the front just says exclamation bin bash. You put the hash in the front, Teja. That's the problem. You see the script here. The starting line has to be a hash and then exclamation bin bash. You do not have the hash. That is the problem right there. Can you add the hash in the front to the shebang and to see if it works, Teja? Let me know if it works. Oops, what's the problem? Let's debug it. Cat fn1. What's the issue here? Function, echo inside a function. Okay, that's the problem right there, the double quotes. Right. Again, line 10 and 12, what is the issue there?
It's MKDA.
Right, MKDR double quotes, and yeah, that's true. Right. So it looks like didn't save.
Doesn't need double quotes.
Yeah, right. And then WQ, V and C. Right, and then cat it. Yeah, and then try to run it. Right, there you go. That worked. That's it. Right. Teja, did you do it? Teja, did it work? So Rahman, did it work for you? Rahman, are you there? Okay, good. So it looks like it's working for Raymond and Teja. Did it work for you? Hey, Teja, are you there? Teja, did it work? Okay, good. Yep, worked for Teja as well. All right then. Chirag, it worked for you, right? Everything is good? Okay, good. Where were we? We were at the functions. Okay, we did the functions. So we stopped here, right? So it looks like they have like two examples of while true and until false loops that I want you to do as homework as well. The same thing that we already did, right? Slide 77 and 78 is basically homework. So we put it here. So this is the homework that you have to do by next class and the lab as well. The lab is attached in the drive, right? We have the Google Drive. When you download, the lab is right here. So till lab 5, everyone has to submit by next week, okay? And let's continue with this next class. So we'll do pattern processing in the lab 6 in next class. Okay, so let's stop here, and we will do the rest of the things, and we'll continue with more lectures, the file system, and with the RPM user registration in the next class. Okay. So any doubts till now? Any doubts till what we've discussed till today? You can ask me right now, or if you get it later, you can email me, text me, call me, right? And I can help you clarify your doubts. So if there is no doubt, I think we are done for today, and we'll continue next week sometime. Okay. So when is the next class? Next class again Sunday 8 a.m. Okay, good. All right. So I'll talk to you guys next week. But in the meantime, if you have any doubts or questions, feel free to email me, text me, or call me, right? And we'll basically clarify doubts. Okay. All right. I'll talk to you later. Bye.
Thanks, Victor.
Thanks. Bye.